Hi all, today we are going to be going over example 12.3.2 in section 12.3. So with this example, we're looking at a random sample of 11 statistics students, and they produced the following data. It's a collection of their third exam scores along with their final exam scores. So what we're going to be doing is looking at, is there any connection between how you did on one exam versus the other? If so, maybe we can try to predict how well someone will do if we know their third exam score on the final exam. So the first step is to look at the data, plot the data, and look at the scatter plot. So we look over at the scatter plot and we see a fairly decent linear pattern here. And so remember, our linear pattern means our data should try to fall on what looks like a straight line. So maybe something like this, maybe something like this. The slope we'll have to figure out of that line. Does it look kind of flat? Does it look almost up and down? The other things we should be looking for are, with the slope, is it positive or negative? Is it going up like this first one? Is it going down like this second one? So looking at this, it looks like as the third exam score increases, we also see that the final exam scores are increasing. So we talked about this previously. When we can see one variable increase and then another variable increase while that first one's increasing, we called that a positive association. Alright, so we saw a positive association before between these two variables, and the way we see that now is, well, it looks kind of like there's a straight line going through here. So in the last example, and in class you've done this with some people in your group, or maybe you and the teacher did this together, you tried to fit this line that I just drew, this red line, in perfectly with your points. Well, what we're going to do is have a computer fit for us. You've already played around trying to minimize your residuals, your residual squareds. We're going to let the computer do that, but we should be thinking before we even do any of that what it should look like, and if after that, what we can do with it. So we put our initial guess down. We think it's a positive association. It looks like it fits, but we should be a little careful here. So even though on the whole, as the third exam score increases, the final exam scores seem to increase, it's not always perfectly true. So if we look specifically right here at this exam score, this third exam score / final exam score, so this would be one student, we notice that there are scores, there are students with third exam scores that are bigger, like right here, but their final exam score actually went down. So it's not a perfect pattern. This is real data, and real data is not perfect, won't fit on perfect patterns, but what we can do is we can try to, on average, find a pattern, and then see if we can learn from it. You probably have been in a class where you did a bunch of homework but didn't do that well on an exam, and your teacher may have said, well, there's a connection between how much homework you do and how well you do on the exam. You also probably may have been this person or knew someone in your class who did no homework but got an A on everything. So there will always be people or instances where it doesn't fit the pattern, but that's okay because we're just looking for a pattern, nothing perfect. So we continue by taking this information, putting it in our applet, which I've already done here, and then what we're going to do, we see the same picture here, although it's a little more zoomed in, which is nicer, so we can kind of see the overall picture. If we want to actually see the regression line, I'll click Show Regression Line, and you can, if you're interested, check out what the residuals look like. You can also show your squared residuals, and you can play around with your own movable line by clicking Movable Line. But at this point, if you feel comfortable with how we've created that line and what it means, then really you just want to work with the line. And the way we work with the line is, well, we take it. So here is your regression line. and we can try to use it. So how did we use this? Well, the original question is, can we predict a final exam score given a third exam score? The way we do that is, well, you take a third exam score, so why don't we try 70? So let's take a third exam score of 70. Okay, so what do I do with that? Well, I take that 70 and I plug it in where it says third exam in my formula. So that would be final exam, right? And a lot of times we're using a hat on that. Well, it's not a great hat, but you can pretend you'd wear that. So we put a hat on the final exam equals negative 173.51 plus 4.83 times 70. So let's see how this goes. We're going to type this in to our little calculator, so hopefully you have one on you that way. So that's 4.83 times 70. So that would be 338.1. I'm still adding, though, negative 173.51 to that. So let's try it. Plus 173.51, and I'll negate that. And I get a score of 164.59. Let me write that down. It's my predicted final exam score. So what we can try to do from this is see if it kind of fits the line. So 70 will go right about here. So then if we move up here, that puts us there. And that looks like it's a little bit above 160. So maybe not perfect, but pretty close to what the rest of the dots look like. If we had a little bit better scale on here, we could see, but that should hit right about 164.5, 165. So, what are we doing here? We are using this regression line to try to predict the values of your final exam based on only knowing the third exam of a student. This is not 100% foolproof. This does not mean that another student coming in to take the test, if they got a 70 on the third exam, that they will 100% get 164 points on the final. This is on average what someone who gets a 70 following this pattern should get on the final exam. Thank you for watching, and I'll be back soon.